All right, so let's take a look at some problems or some examples at least from chapter 2. So here's the first one is a group problem solving problem that you can find in the slides from the publisher. So in this particular case, it's a chapter 2, typical chapter 2 problem. There's three forces acting upon a point that's in the center of the xy plane. Uh, you want to find out what the magnitude and angle of the resultant force is. So remember when you see magnitude and angle, remember polar form, we've talked about that before. That's what they're looking for. So in this particular case, I'm going to show you my approach to it. Again, I like to try to reference everything from the positive x-axis in a counterclockwise fashion. You can't do that obviously with F1 because they give you the 3, 4, 5 right triangle. So here's my approach. So if you take a look at this drawing, and it's beautiful as you can see. There's my free body diagram for the problems that we just had. You can see F1, I've got with a 3, 4, 5 right triangle and 850 newtons. F2 is 240 newtons from the positive x-axis, and F3 is 135 off of the positive x-axis. So here's what I did. It looks like I started with F3 and whatever reason. So F3 was 750 newtons at 135 degrees. I took and plugged that into my calculator, just like that, converted from polar to rectangular, got my XY components for it. I just wrote that newtons down at the end there just so that I remember what the units are, because I tend to forget if I get distracted. So F2, the same thing, recorded it in polar right off of the drawing, used my calculator, converted that to rectangular. Here's the XY components. And for F1, I used the 3, 4, 5 right triangle, got the X and the Y components. Right, so if you remember now, the resultant is going to be adding the three together. So we can add all the X's, we can add all the Y's, which I've done here. So you can see I've got all the X's together, I've got all the Y's together. The top one, well, the one minus 162.9 in the I direction and minus 520.9 in the J direction. Those are the answer in rectangular form. Of course, they asked for us to give the answer they wanted the magnitude and angle. So when you plug that into your calculator and ask to give it back into polar, you're going to get the first answer I've written there, 546 newtons at minus 107 degrees. Now, the plus direction is counterclockwise, minus is clockwise. So if you take 360 minus 107, you get 253. So either one of those answers would be correct. 546 at minus 107 applies clockwise from the x, and the 250 degrees assumes counterclockwise, which is the way that I originally started the problem. The solutions from the author are there. You'll see very similar results. You actually see exactly the same results. If you're comfortable with what I did, great. If you're comfortable with what the author did, that means you got a real good understanding of trig. That's great too. And you'll find that when we get down to the end, we have the exact same answer. And I didn't draw it on my paper, but you can see the answer is drawn out there. So there you go. There's a example from chapter 2.